RBS Business Research Academy welcomes you in the lecture number 4. In this lecture number 4, we have to understand about the concept of the reliability and the validity. So dear friends, reliability and the validity are very important concept of the measurement model. How to understand the reliability and the validity, that is the job of this lecture number 4. So let's start to understand the reliability and the validity. But before this one, my name is Dr. Rahim Sumro and I'm working as a professor in the Validity University, Pakistan. So if you want to contact me, then my email address, my website, Facebook page and YouTube channel are also available where you can contact with me. So now there are the two types of the measurement model, reflective measurement model and the formative measurement model. So these are our loadings, and when we are working on the reflective model, so all these items are the item x11 to x30. These are our items, so we call them as a loadings. When we work on the formative, then we call them as a weight. So now please identify the pointation of the arrow. When the arrow is coming from the latent variable to its indicator, like this is the arrow, this is the pointation of the arrow, this is called the reflective. When the reverse process is there, for example, the arrow is coming from the item to its latent variable, this is called the formative model. So in the formative model, now these are x11 to x23, these are called indicator, item or manifest variable. Anyone you can give the name to all these one. And then another is so now these y1 and y2, these are our exogenous or independent variable, while y3 is our endogenous variable, latent variable. So alternative we call is a dependent variable. So in the structural model or in the inner model, basically we are going to test the path. Path means that the impact of y on the dependent variable, and the impact of the y is an independent variable on the dependent variable. So now this card is a path. Along with the path, we can also compute the R square. So that is a basic job of the structural model. So now when we are to when we talk about the measurement, then we have the different variable like the age, height, and the weight. So now these are different tools are there through which you can measure exactly the weight or height or age of any person. But when you talk about the latent or unobserved variable, then it is really difficult to measure, because latent variable or unobserved variable is that of the variable which cannot directly measure. For example, we cannot directly measure the ability of any person, attitude, opinion, feelings, or performance, or personality trait, or even the interpretation, because all these are our unobserved variable. So now to measure the latent variable formal, we need a formal questionnaire. So now another thing is the reliability of instrument. So first thing is the reliability is synonymous with the consistency. That means the up to what level the respondent has remained consistent in answering the questions of which you have asked in your questionnaire. And another thing is the extent to which the assessment tool produces stable and consistent results. So now the one is about the consistency, and another thing is that we have to assess the consistency of the tool. It means the survey instrument, and also we have to check the consistency of the response. Either the respondent has remained consistent in replying all the answers. So therefore, the reliability reflects the whether an instrument it produces constant results when applied in the same phenomena in the same condition. So that's very important, that the same phenomena and same conditions are, but whenever you are like administrating any questionnaire, any instrument, to check its reliability, the phenomena should be same and the conditions should be same. Otherwise, the same result or consistent results will not be produced by the same instrument. So now this is one instrument where the name of this one construct is there when we want to check the independent intention, and these are the items of this one. So independent 1 to independent 5. So these are the statements of each item. So now we have to check the reliability of this independent scale intention, that either it is going to measure the same thing every time or not. So now the loading. So minimum value of loading, each loading should be 0.078. Should be this one or higher than this one. So next. Validity is another important term where we refers to the extent to which the construct measure what it's supposed to measure. So now, for example, if any instrument, any construct has been developed to measure the interpreted intention, we have to make it sure that the construct is going to measure the interpreted intention actually or something else. If it is measuring interpreted intention actually, then it is a valid instrument. So now validity, there are two types of the validity. One is a convergent validity. Convergent validity will be established when there is a positive correlation between the interpreted intention 1 and interpretation intention 2, interpretation intention 3 and 5. When there is a positive relationship among all the items of this construct, that means our convergent validity has been established. And then to establish convergentity, we have to check about the outer loadings. Like these are the outer loadings 0.708. If any values is less than 0.078, that item should be deleted. And another measure to measure the convergibility is the average variance extracted. So now these are the two popular measures of the convergibility. One is the outer loading and another is the average variance extracted. Convergibility as an established rule of the thumb is that the latent variable should explain substantial part of the each indicator, usually at least 50%. So now this means that the outer loading should be above 0.078, because when we square the 0.078, it will become 50%. So at least there is a contribution of every indicator in its construct should be more than 0.5 or more than 0.5. So path coefficient square root is a 0.85. When we take it square root of the 0.078, it will become the 0.5. So here, so now for example, interpreted intention 1, variance of interpreted intention 1 to variance of the interpreted intention 5. If you add all these one and divide it by the 5, so now we can get the average variance extracted of that construct. So now for example, if we want to take the AV of this one, then we have to take the average of all these one. If the average of this one is the more than is a 50% or more than 50%, then the convergent validity has been established. Now, measures of reliability. So first thing is the internal consistency. Now it can be computed with the help of the Cronbach alpha, and then if value is 0.7 and above, then the reliability has been established. But with some exceptions. Exception is that if you are working on exploratory research, then 0.6 to 0.7 is even acceptable. So Cronbach alpha is the lower bound and composite reliability is the upper bound of the internal consistency. That means the CR, composite reliability, as well as the Cronbach alpha, both are basically measuring the reliability of an instrument. Another tool to measure the reliability is the indicator's reliability. So now the indicator's contribution in its relevant construct should be 0.708 or higher than this one. And even though if the loading is between the 0.4 to 0.7 should be considered for the removal if the deletion leads to increase the composite reliability and the AVE. So now if you think that by deleting any indicator where the value is even less than 0.7 but it is higher than 0.4, then if you think that by deleting this indicator will increase the value of composite reliability and the value of AVE, then it should be deleted. But if the vice versa case is there, then it is better to keep that indicator within the model. But if already the reliability has been achieved, then there is no need to delete any indicator which is equal to the 0.4 or higher than this one. But that any indicator which value is loading is 0.4, outrightly it should be deleted. And then another is the AVE above suggested threshold value is the convertibility. AVE should be 0.5. So in order to measure the discriminant validity, we have the several criteria. The first criterion is the HTMT heterotrait monotrait criterion to assess the discriminant validity in the PLS-SEM. The confidence interval HTMT static should not include the one for all combination construct. According to traditional discriminant validity assessment or indicator, outer loading on the construct should be higher than its all cross loading with the construct. Okay, and then another is a furthermore square root of the AV of the each construct should be higher than its highest correlation with any in the former Larker criterion. Furthermore here. So now the first thing is a indicator reliability. If the items reliability is more than 0.07, that's good thing. Indicator consistent reliability is what? The composite reliability in Cronbach alpha is if it is greater than 0.07, that's good thing. Rho A, if that is also higher than 0.7. So now when you are running the SmartPLS, you are getting the two measures of the reliability. One is a Cronbach alpha. So now this one is a Cronbach alpha. Its value should be 0.7 and above. Another is a composite reliability, and it can be measured with the help of the rho A. So now if this value is higher than or equal to 0.07 or higher than this one, then you should be happy that the internal consistency has been achieved, which can be measured through two tools. One tool is a Cronbach alpha and another tool is the composite reliability. When you talk about the validity, so now conversion validity, if the AV is higher than 0.5, so now it means that our convertibility has been achieved. And another is the divergent validity. It means that now the two tools are available. For the Larker criterion, diagonal estimates should be higher, and the heterotrait monotrait ratio ATMT, all the values should be less than 0.85. So now in the video lecture number 5, practically I have discussed that how you can check the heterotrait monotrait in SmartPLS-4, formal Larker criterion in SmartPLS-4, convertibility, internal consistency, and indicator reliability in the SmartPLS-4. So if you are interested, you can also go on this video, and then you can practically know about all these measures of the reliability and the validity. So now discriminant validity is already I told you that the extent to which that a construct distinct from the other construct. This can be measured with the help of the cross loading and the former Larker criterion. So indicator loading on the construct should be higher than all cross loadings, and another is there the square root of the AV of each construct should be higher than the correlation in any. So now these two are there. It means now that when we want to measure reliability, we have the two measures. One is Cronbach alpha and is a composite reliability, and when we are going to measure the validity, then we have the discriminant validity. That we have again two tools. One is cross loading, another is the formal Larker criterion. So another, if the outer loading is less than 4, delete it out outrightly. Okay, and then if the outer loading is higher than 0.7, retain the outer loading indicator. And other thing is that outer loading is in between the 0.4 to 0.7, then analyze the impact of indicator. Okay, deletion increase the measure above threshold, then delete the reflective indicator, and if the deletion is not increasing, then retain the reflective indicator if its indicator's value is in between the 0.4 to 0.7. Now here outloading, again another thing, the outloading, if it's a green, then okay, so now AV, CR, alpha, Cronbach alpha, RO, if all are the green, that means reliability and the validity has been achieved. The good thing in SmartPLS is there. So whenever all the values are in the green, as you are looking in this image, that means you should be happy that there is no any problem. But any image which is any value which is in the red circle, red color, then you should be concerned over there that there is a violation of the rule of the AVCR Cronbach alpha rho. So now another thing is about if any auto loading is in red, then the probably there's a problem with the AVECR colon alpha. So if it is a green, do not delete the item, but if it's a red, delete the item with the lowest loading, and but delete by one. If there are the several items are there whose loading is less than 0.4 or less than 0.7, so now you should delete one by one. So when you are deleting one by one, probably there are chances that you can achieve the minimum threshold of the reliability and validity by deleting minimum indicators. And then, okay, if the AVECR alpha row are achieved, then delete the variable. Okay, and even if you are unable by deleting all these ones, you are not getting the green values, still the red values are there. Then there are the three problems are there with your data. Problem in your data, probably problem with the outlier, and the problem of the unengaged response. So that whenever even you are getting the red values, then these three problems are with your data. Now unengaged response, you're looking here in the red circle, there is the agree. So all these are the unengaged response. For every question, for every item, you are looking at the every time the agree or the fourth choice has been selected by the respondent. So this shows that there is an unengaged response problem with your data. And now here you're looking at the unengaged response 5, 5, 5, 5 against every indicator, 1 against every indicator, 3 away. So now this shows that the unengaged response issue with your data. Okay, so in order to identify unengaged response, first you are required to copy all the values and then from the results, and then paste those one into the Excel, and then by using this formula you can find out any unengaged response. If there be any unengaged response in your data, that will be shown with the 0. So now looking that these are the 0. Otherwise, against all other indicators, there is only 0. So another issue is of outlier. So as you're looking here in this window, you are finding one important, that's 34. So actually 34 is out of the range. So we have range 5-point Likert scale from 1 to 5. So this one is outrightly away. So this 34 is out of this range. So therefore we consider it as an outlier. So thank you very much for watching this whole video. I hope that this video has clarified your concept regarding the reliability and validity and the different tools to measure the reliability and validity.